Vibe coding is fast, until it removes your brakes. It's a seductive loop. You describe what you want in plain language, an AI tool spits out code, and the demo looks great. The trap is thinking the demo equals production. The document's core warning is blunt: confusing adoption speed with proven effectiveness leads to vulnerabilities, tech debt, and decisions no one can audit later. Vibe coding, a term Andre Karpathy coined in February 2025, with a post hitting 4.5 million views, scaled because it kills friction, I ask, the AI writes. But the document draws a hard line: adoption isn't maturity. Daily usage reportedly sits between 72% and 92%, GitHub Copilot has 20 million plus users, and yet none of that proves quality or safety. It mostly signals functional dependency. You'll walk away with 3 practical outcomes. 1. What's documented to be failing in security and productivity. 2. How tech debt shows up as the spaghetti point. 3. What to do in real teams without falling into compliance theater or blind faith in SAST/DAST. The basics: what vibe coding is, and why it spreads. In the document, vibe coding is straightforward. You describe what you want in natural language and an AI tool generates the code. That simplicity explains the surge. It also explains why teams adopt it without guardrails. One metric in the document says more than user counts: trust versus dependency. Developer trust in AI tools dropped from 43% to 29% over 18 months, while usage climbed to 84%. That doesn't scream delight. It looks like the tool became embedded even as confidence declined. A common mistake follows: if it compiles, it's fine. The document pushes back: models have improved at producing code that compiles, but not at producing code that's secure. That difference should reshape how you evaluate AI output. Security: the works versus secure gap is documented. Across the curated sources, the document highlights a consistent direction: AI-generated code has serious security issues. Reported vulnerability rates vary between 15% and 45% depending on the study. But the document adds a crucial constraint: you can't cite a single, true rate, without methodology, because these numbers aren't directly comparable. A strong example: Veracode tested 100+ large language models, LLMs, across 80 tasks and reported that 45% of generated code contained OWASP top 10 vulnerabilities. In Java, the failure rate hit 70%. It also reports very high failure rates for cross-site scripting, XSS, 86%, and log injection, 88%. Now the uncomfortable part 4, it'll get better next year, narratives. The document states that 2 years of model improvements haven't significantly reduced vulnerability rates. Models got better at compiling, not at being secure. Even security-focused prompting has limits here. The document notes that Claude Opus 4.5 produces secure code only 56.1% of the time without security-specific prompting, and techniques like security prompts, self-identifying common weakness enumeration, CVE, or direct vulnerability hints didn't reliably close the gap between functional and secure. The bias that breaks your dashboards: assisted Dunning-Kruger. Stanford documents an assisted Dunning-Kruger effect: developers using AI assistants write less secure code while feeling more confident it's secure. If your org relies on self-reported quality, I feel faster, looks safe to me, you're measuring confidence, exactly the thing the document says is distorted. Cloud Security Alliance reports that 62% of AI code contains security flaws and that 69% of organizations found vulnerabilities introduced by AI-generated code. The document still cautions against mixing these figures without methodology, but the direction reinforces the risk. From theoretical risk to CVEs, the ecosystem is an attack surface. This stops being abstract when CVEs show up. The document states that in January 2026, 3 common vulnerabilities and exposures, CVEs, were recorded affecting central tools in the ecosystem. CVE 2025-54135, Command Execution via Cursors Model Context Protocol, MCP. CVE 2025-53109, Anthropic's MCP server allowed unrestricted read/write. CVE 2025-55284, DNS exfiltration in Claude Code. This doesn't prove everything is insecure. It proves something operationally useful. There's real, cataloged attack surface. If your plan was, we'll deal with it later, this is the reason not to. Productivity, perception versus reality, and why it matters. The document cites one experimental study with randomized controlled methodology, METR, with 16 developers. The outcome is sharp. Developers using AI believed they were 20% faster, but they were actually 19% slower. The document also flags the obvious limit: you can't generalize from 16 people to the whole industry. Still, there's a practical takeaway you can use today: developer perception isn't a reliable productivity metric when AI assistants are involved. If your business case rests on, it feels faster, you're building a story, not evidence. Stories don't pay for incidents. Tech debt, the spaghetti point and the month 3 cliff. The document describes a recurring pattern called the spaghetti point. Around month 3, adding features breaks existing ones and development speed drops close to zero. In practice, fast-generated code tends to grow without consistent structure unless design, review, and tests are in place. There's also a metric style signal. Google DevOps Research and Assessment, DORA, found that a 25% increase in AI usage correlates with a 7.2% decrease in delivery stability. Forrester predicts that 75% of tech decision-makers will face moderate to severe tech debt by 2026. The document also notes that the $1.5t tech debt figure for 2027 is an estimate, not a fact. Don't sell it as certainty. Then there's the perverse incentive. 54% of engineering leaders plan to hire fewer juniors due to AI efficiencies, while AI-driven tech debt still needs human judgment to unwind. Cutting the talent pipeline while complexity rises is a medium-term bill you'll eventually pay. How to implement AI coding without gambling. The document isn't asking for a ban. It's asking for governance and real verification. Step 1, make success measurable, not emotional. Use outcome metrics that don't depend on self-reporting, delivery stability, production defects, true cycle time, confirmed vulnerabilities, rework. The document explicitly warns that self-perception gets contaminated. Step 2, build foundations before frameworks. Frameworks help only if your basics are real: CI/CD, code review, and automated tests. Without them, frameworks become empty bureaucracy. Step 3, use governance frameworks with nuance. The document mentions ISO/IEC 42001:2023, an AI management system, MS, and NIST AI RMF with 4 functions: govern, map, measure, manage. It also references EU Regulation 2024/1689, EU AI Act, applicable from August 2, 2026 for high-risk systems, with fines up to €35 million or 7% of global turnover. But nuance matters. Using an agent to code doesn't automatically make your product a high-risk AI system. The document warns against oversimplifying a complex legal framework. Step 4, don't assume SAST/DAST covers what AI breaks. SAST and DAST in CI/CD are presented as mitigations, but the document stresses they weren't validated specifically against AI-generated vulnerability patterns. Assuming coverage is not the same as verifying it. Step 5, if you log prompts, don't turn it into theater. Prompt logging only helps if someone reviews and uses it for traceability decisions. If it's just paperwork, it's compliance theater. Common failure modes, so you can avoid them. Mistake 1, treating adoption as maturity. Usage rates measure usage, not competence. Trust drops while dependency rises, functional dependency, not endorsement. Mistake 2, believing multi-agent setups magically fix quality. The document mentions multi-agent proposals: architect, developer, auditor, security, but states there's no evidence that agents auditing agents reduce documented vulnerability rates. Mistake 3, using taxonomies instead of operating processes. The intention, restrictions, verification, IRV, model is reasonable conceptually, but the document says there's no empirical validation in real organizations. Without defining verification and measuring it, it's labels without substance. Closing, it's not about shipping faster, it's about crashing less. The document's central claim is clear: vibe coding isn't a mature revolution. It's functional dependency with documented risks, improvised governance, and success metrics that confuse adoption with outcomes. 3 takeaways you can act on. 1. Measure real outcomes, not perception. 2. Build foundations, CI/CD, review, tests, before frameworks. 3. Validate security and quality for your AI use instead of assuming coverage. If you found this helpful, consider supporting my work. ko-fi.com/luisospina21292. Or reach out for professional consulting. info@vvc-consultor.com